Hello students. So today we are going to learn about the real numbers. This is for the 10th class. So real numbers. So what are real numbers? So first we need to understand from your previous classes like what is a, okay, let me draw this line with the numbers. Let's say 0, 1, 2, 3, 4 and so on, and also -1, -2, -3, -4 and so on. This is what you see in your graph. Okay, so let's consider these numbers, okay, from 1 to 3 like that. So these are called natural numbers, right? So these are called natural numbers. And natural numbers, 0 is not a natural number. Natural numbers along with 0 is called a whole number. Okay? So natural numbers combined with 0 are called whole numbers. And similarly, you have -1, -2, -3. Okay? So we can call these everything together as integers, right? So integers are natural numbers and whole numbers and also the negative numbers. So -1 we won't call it as a natural number, that is called as an integer, and 1 is an integer, 2 is an integer. Okay, so any number which doesn't have a fraction is called an integer. Okay, any number which doesn't have a fraction is called an integer. So it can be from -infinity, 0 to +infinity, right? So that is called integers. Now there are other things that you might have learned. What's a rational number? There are two things, rational and irrational. So rational number is something which can be written in the form of P by Q, okay, where Q is not equal to 0, because if the denominator is 0 in a fraction, then that is not determined, right? So that's why Q should not be 0, and P comma Q are integers. Okay, so a number is called as a rational number when it is written in the form of a fraction. You can say P by Q, where Q is not equal to 0, that is the denominator, and P comma Q are integers. So if that is the form you can write, then that number is called a rational number. So for example, what could be the examples of rational number? 1 by 2, -2 by 3, 4 by -5, right? So P comma Q are integers. It can be positive integer or it can be a negative integer, but Q should not be 0. So I cannot write it as 5 by 0. So this is not a rational number because 5 by 0 is not determined. Okay, so that is rational number. So what is irrational number? Irrational number is nothing but opposite to this. Okay, so irrational number is also something which can be written in the form of P by Q, but okay, so I'll tell you an example. Let's consider 1 by 2 is a fraction, and also 1 by 3 is also a fraction. Okay, so 1 by 2, if I divide it, comes as 0.5. So it has a terminating end when you write into the decimal form. 1 by 3 you can write it as 0.333 and goes on. So a number which is when you write in a decimal form, it doesn't have an end, it doesn't terminate. Those kind of numbers, those kind of numbers, when they have a repeat pattern, So this is not, this is repeating like 333. And if you consider, for example, pi, what's the value of pi? 22 by 7, which is 3.1. So 10, right? 7 1 7, so you still have 3, 4, 28, you still have 2, which is 20, 3, 6, 18, again you have 20, so 3, 6, 18, okay. So that's how it goes on, right? So it repeats after a certain interval, like root 2. 1.414, like this. It repeats like root 3. Okay. So this all repeats like 1.721, like this. So when you write a number into a decimal form, there will be a pattern in the decimal forms which will repeat. Those kind of numbers are called irrational numbers. Okay. So for example, the irrational numbers, the example are pi, root 2, root 3, etc. So these are irrational numbers. So we need to understand what are the different numbers, right? So as of now we learned what's a natural number. Natural number is like from 1 to infinity, 1, 2, 3, like that. And when a natural number including 0 is called a whole number. And then a negative numbers like minus 1, minus 2, minus 4. So minus infinity to 0 up to plus infinity, they are called integers. And we also have something called rational number. Rational number is something which can be written in the form a by b or p by q, where q is not equal to 0 and p and q are integers. Okay. So these are the examples like 1 by 2, minus 2 by 3, 4 by minus 5. 5 by 0 is not a rational number because 0 is, when any number is divided by 0, it is not divisible, it's undetermined. So q is not equal to 0 by the definition itself. Okay. So the denominator should not be 0. And also you have irrational numbers. Irrational numbers are something like when you written a particular number in the form of a decimal, that decimal will have a pattern, it repeats and it doesn't terminate. So those kind of numbers are called irrational numbers. For example, pi, root 2 and root 3. These are all the irrational numbers. So now we learned about all the different numbers. Then what is a real number? So real number is a superset of everything. Okay. Let's say this is a natural number. Okay. This is a natural number set, and let's write this is a natural numbers along with the 0 is a whole number. So it is a superset of natural numbers. So this is a whole number, and then integer is a superset of both natural and whole. So these are integers. Integer set, let's say. Okay, this is integer. Then what is a rational number? So rational number is again a superset of this. So that's a rational number. And irrational number is not part of this. Irrational number is not a natural number because 1.414, 414, 414, and it's not a whole number, it's not an integer, and also it is not a rational number. So it is a different. So there is no intersection between rational numbers and any of these. So we can draw this as a separate set, that is a rational number, right? And then what is a real number? Real number is the superset of everything. Okay, if I write like this, so this is a real number. Okay, hope you understand now. So real number is a set of everything. Okay, is a set of the natural numbers, the union of, I would say, the union of natural number, whole number, integers, rational and irrational. Everything is put together is called as a rational number. Okay, so this is the rational number, and now we will move on. Okay, so hope you by now you understand what's a natural number, whole number, integer, and then rational, and then irrational, and then what is a real number. Real number is a union of all these. Okay, hope you got it. Now I will move to the next concept. Okay, so for a few examples you can call out, okay, just to get into this. So I would say those examples like 2 by 5. Okay, for example, 2 by 5. So if you write this into a fraction, it comes as 0.4. Let's write 17 by 18. Okay, 17 by 18 I can write as 0. Because 17 is lesser than the denominator, so it becomes 170. 170, if I write by 9 times, it is 162, right? So I left with 8, and then I can add 0, so it is 80. So 80 divided by 18 is 18 fours 72, and then I am left with the 0, adding 8, so which is 4. Again 80 by 18 is 4. So 17 by 18 I can write as 0.9444, and it goes on. And 2 by 5 I can write it as 0.4. So this is a fraction which is terminating. It stops like 0.4. That's the decimal form of it. And 17 by 18 it doesn't stop. It is non-terminating. Okay. So this is what the difference you need to find. So a terminating fraction or a rational number is which will end, and it can be written as a complete decimal form. And there are few rational numbers which cannot be terminated. They can be written as non-terminating in terms of the decimal form. Okay, this is just an example. You need to understand what is a terminating decimal and what is non-terminating decimal. Okay, now let's go to next one. Okay, so we learn something about the factors method. Okay, by now we understand what is the different types of numbers and what is a real number. Right. Now let's understand what is the factors method. So factors method is something, a given number you can write in the terms of prime factors. Let's consider an example 163800. Okay, this is a big number. I want to write it in the form of factors of the prime numbers. Okay, so what are the prime numbers which are divisible by their own, like 2? So what are the prime numbers? Let's say 2, 3, 5, 7, and 9 is not a prime number. It's an odd number but not prime number. And then we have 11, 13, and so on. Okay, so these are the prime numbers. And I have this number 163800. Okay, so this I can write in terms of prime factors. So I will tell you why we are getting here. We are getting here, the next concept we have is the HCF and NCF, the highest common factor and also the lowest common multiplier. So to get there, we need to understand how we can factor a number. Okay. So now any number, first you check with 2. If it is not divisible by 2, then go to the next prime, which is 3, or next prime 5, or next prime 7. Okay. So first let's say whether it is divisible by 2. I think so, because it has a 0 at the end. So 0 can be divisible by either 2 or 5. That's the only things. The other prime numbers it cannot divide. Okay. Let's see 2 8s 60, and then I have 2 1s, and then 2 9s, and then 0 0. Okay. So it is divisible by 2, and it has 81900. And let's again try this with 2. 2 4s 8, and then 2 9s 18. I have 1 with 0. It's 2 5s 10 and 0. Alright. So let's try again with 2. 2 2s, 2 4s 8, and then 15, 2 sevens 14, and 2 fives 10. So now I have a number which is ending with 5. So I cannot divide this with 2. Whether it goes with 3, I'm not sure. So let's check quickly. 3 8s 24, 3 2s 6, 3 5s 15. Yeah, it goes. So let's try with 3. So 3 8s 24, and then 3 2s 6, and I have 15, 3 5s 15. Right? So it is now coming as 825. And let's divide this with, let's check quickly with 3. 3 2 6, 22, 3 sevens, yeah, it goes with 3 again. So 3 2 6, and I have 22. 3 sevens 21, and I have 1. 1 and 5 is 15. 3 5s 15. Right? And similarly, you now check with 3. 3 9s 27, but it is left with 5. So it's not anymore divisible by 3. So let's now go to the next 5. So 5 can divisible by only 5, I guess. Yeah. So let's check 5. So 5 4s 20. Sorry, we have a higher number here. So 5 5s 25, and again you have 2 left. So it's again 5. And then if I write it again with 5, 5 11s. So 11 is a prime number which is not further divisible, right? So is that true? Let me quickly check. Think somewhere I made it wrong. Hold on. This is not true. 2 times is 4. So I made a mistake here. Let's see, guys. So 4950, right? Twice is not 81,000. Okay. So I should have checked this. So everything would have gone wrong. Okay. So when you divide by 4, it is 4. The next is 1. So I need to take 0 here. Yeah. So 2 8s 19, and then 2 5s 10, and then 0. Yeah, this is the correct. Okay. Next again try with 2. 2 2s 4, and 0, 2 4s 8, 2 7s 14, 2 5s 10. Okay. And now let's go with 3. Check with 3. 3 6 18. You have 24. Okay. Let's directly go with 3. Yeah. 3 8s 24. Sorry. 3 6 18. And then I have 2 and 4 24. 3 8s 24. And then I have 7. 3 2 just 6. And then I have 15. 3 5s. Okay. And let's see whether it's divisible by 3 further. 3 2 6. 3 2 6. 22 I have. So 3 7s 21. And then I have 15, which is 3 5s. Okay, 2 2 7 5. Let's divide it further with 3. 3 7s 21, and then I have 17. So 3 5s 50, and then 25, which is not divisible by 3. So now I need to go check with 5. So 5 4s 20, 5 5s 25, and then I have 5 5s 25. Okay. And now you further divide it with 5. 5 9s 45, and 5 1s 5. So 19 I have. Sorry, 91 I have. So 91, is it a prime number? Let's check. It's not divisible by 5 anymore. So let's check with 7. 7 ones 7. I have 21. 7 is 21. Yeah. So now I am left with 13. So 13 is a prime number. It is not further factorized. So yeah, that's where you factorize the number. So 16380 can be written as 2 into 2 into 2 into 3 into 3 into 5 5 into 5 into 7 into 13, right? So when I write in terms of the prime powers, so I have 2 into 2 into 2, I can write 2 cube, and similarly 3 into 3, I can write 3 square, and 5 into 5, I can write 5 square into 7 into 13. So this is the way you can write any number in terms of the prime factors. Okay, you take any number and first check with the 2, if it is divisible by, then further factor it, or if it's goes to a level where it is not divisible by 2, next check with 3 and you continue, and it goes to a level where it is not divisible by 3, then you take 5, you take 7. So like that until you get a last number which is a prime, which is not further divisible. And when you write all the multiplications you get, so you will get like this, and you can write them in terms of the powers of a prime number. Okay, so this is very important to understand how you can write a number into a prime factors. Okay, so now we will learn what is HCF and what is LCM. Give me a minute. Okay, so I'm back now, and let's learn what is HCF and what is LCF. Okay, let's take a small some examples of two numbers, 12 and 18. Okay, I am taking two numbers and I am trying to write them in the powers of prime factors. That is what we just learned. Okay, 2 I can write it as 2 into 6. So 6 I can write as 2 into 3. So 12 is 2 into 2 into 3, which is 2 square into 3, right? Okay, so 12 I can write as 2 square into 3. And similarly 18 I can write as 2 into 9, and 9 is not divisible by 2, so I will check with 3, so 3 into 3. So 2 into 3 into 3, so that is 2 into 3 square. So always write in the form of prime powers in ascending order. If you have 2 into 3, you multiply from 2, 3, 7 like that. Okay, in the ascending order of the prime. So 2 square into 3 here, 2 into 3 square. So now let's learn what is HCF. So HCF is the highest common factor, and it is how you can come to the HCF is when you return two numbers into a prime factors, then the smallest powers of the factors, you need to multiply the smallest powers of those two numbers when you have written into the prime factors. Let's say I have two things here. So for 12 and 18, I have written into the prime factors, that is 2 square into 3 and also 2 into 3 square. So the HCF is the smallest. So what is the smallest power in these factors is, so 3 I can also write as 3 power 1, and here also 2 power 1. So the smallest is 1. So I have two powers here, 3 power 1 and square I have, 1 and 2 I have, here also 1 and 2 I have. Okay, so what is the smallest powers? The product of the smallest powers. Okay, so 3 power 1 to 2 power 1. So 3 into 2 is 6. That's the HCF of these two numbers. Okay, and similarly, what is the LCM? That's the lowest common multiplier. Is the largest or the greatest powers. What are the greatest powers? So 2 square I have, and also 3 power 2 I have. Okay, so if I have a 2 cube, then that is the greatest. So I should consider 2 cube, the power. Okay, and similarly if I have 3 power 4, that 4 is the highest, so I need to consider 3 power 4 as the greatest power prime. Okay, so here I have 2 square into 3 square, so that is 4 into 9, that is 36. So the LCM is 36. Okay, hope you understand how to get to a highest common factor and the lowest common multiplier. So what you need to do is, When you have two numbers, you factor those numbers into the prime factors. You can write them into the powers of prime factors, and then what is the highest common factor is the product of smallest powers of primes. So in this, what is the smallest one? 3 power 1, 2 power 1. So 3 into 2, which is 6. And the lowest common multiplier is the highest. Okay, the highest or the greatest powers. The greatest powers in these factors are 2 power 2 and 3 power 2, which is 2 square and 3 square, which is 36. So you can take any two numbers and you can find the least common least common multiplier and also the HCF. So that's how you calculate LCM and HCF. So hope you understand this. Okay, now let's move further. Let's move further and understand when you are writing these things, right? So there are some questions which come as to find whether a particular number which is already represented in the form of the powers is a number which can be divisible by something. Okay, like there is a question which says, let's find the number 4 power n or anything or 6 power n is divisible by it ends with a digit 0. Can we do that? Okay, so the question is, I have a number 4 power n and I also have a number 6 power n. Can we write this number? Can this number for where n is a natural number, n is 1 up to anything like 6 power 1, 6 power 2, 6 power 3, whatever. So for any integer n, for any natural number, you say, don't consider integers now because integer is a minus value as well. So let's consider n is a natural number. So 4 power n and 6 power n, where n is 1, 2 and so on. And the question is, for any value of n, do we get a number which ends with 0? Okay, so I can say 4 power 1, 4 power 2 like that, right? So 4 power 1 is 4, 4 square is 60, like this, it goes on. And if we go like 4 power 100, whether it comes with 0, so that is something we can factor in. So 2 power this, right? So what I can write it as, 4 I can write it as 2 into 2, which is 2 square whole power n, that is 2 into 2 power n. To get a number, a 0 at the end, we must have a factor as 5. 5 into 2, 10. 5 into 4, 20. 5 into 6, 30. Right? 5 into 8, 40. So, we must have a factor 5 to get a number which ends with 0. So, in this, there is no 5 as a factor. So, the 4 power n you can always represent in the form 2 into 2 power n. So, there is no factor 5. So, that's how this number, this series will never come with a number which ends with 0. Similarly, let's find 6 power n. 6 power n I can write as 2 into 3 whole power n. That is 2 power n into 3 power n. But I don't see 5 as a factor here as well. So, this number will also never end with 0. Let's consider 10 power n. Okay, 10 power n. So 2 into 5 I can write it as, so 2 power n into 5 power n. So yes, there is a possibility that this number, as it has a 5 as a factor, can end with a digit 0 at the end of any of the number given n is 1 to 10. Okay, so thank you for listening to this.